This set of slides were organized by Professor Alemi and narrated by Farhat Fazelyar. This section of the course introduces you to standard query language and key commands within it. SQL is a standard language for accessing and manipulating relational databases. SQL is an American National Standards Institute standard. Its core commands are the same across vendors. The current standard is from 1999, which is incredibly long time for a standard to remain stable. This is in part due to the fact that SQL is well suited to the task of data manipulations. The data manipulation language is designed to add, change, and remove data from database. In this section, we primarily focus on data manipulation commands. Some examples of SQL commands include commands to retrieve data from a database, to insert data in a database, to update data already in the database, and to delete data from a database. SQL also includes data definition language. These commands are used to create a database, modify its structure, and destroy it when you no longer need it. We later discuss how one creates tables or deletes them. There are also different types of tables. There are, for example, temporary tables of data that delete when you close your SQL data management software. SQL also includes data control language. These commands protect the databases from unauthorized access, from harmful interaction among multiple database users, and from power failures and equipment malfunctions. We will not cover these commands in this course. The list of SQL commands is short. That is good news. Your task is simple. The bad news is that these commands can be used in a variety of ways to accomplish different tasks. In this section of the course, we go over 5 of these commands: select, into, from, where, and group by commands. One usually learns the format for the command through searches on the web. I assume that you can do so on your own. In fact, whenever you run into an error, you should always search for the error on the web, and you will see many instances of others posting solutions to your problem. Do this first because this is the best way to get your problem solved. Most students of SQL admit that they learn more from the web searches than any instruction. The beauty of such learning is that you learn just enough to solve your problem at hand. We focus on the concepts to make sure that these commands are well understood. We demonstrate these commands and manipulation of the data that you have previously imported into the database. If you haven't done so, go back and do so. We show you one example of the command and leave it up to you to learn the format and other examples of the use of the command. You cannot learn SQL without practice, and you cannot practice without downloading some data. Here we see the format of the select command, usually followed by a field name. The SQL commands are usually written in all caps to separate them from the other elements in the code. Here we see the select command asking the software to report on a variable or field name called ID. If there are more than one field, the fields should be separated by comma. This convention is to start each field name with a new line preceding with the comma, so if one wants to delete a field name, one can easily do so. Here are the selecting fields ID and diagnosis. We need to also specify where the fields will come from, in particular which table in our database will the fields come from? The from command does so. This command says that we should select ID and diagnosis from the table called data. The hashtag before the data says that this is a temporary file that will disappear once we close the database. The from command says that the table data is a permanent table inside the database. This word dbo is referring to the fact that the table is inside the database. If you download data into a database, then you would use the dbo to indicate where it is. You would also need to make sure that the software knows which database you have in mind. You can do this in two ways. You can add the name of the database to the prefix of the file name. Here we are saying that the database is called diabetes. You can also use the use command to specify the name of the database throughout your code, so you do not need to repeat this often every time you read data. The INTO command writes the manipulated data into a new file. In this code, because the name of the file is preceded with the hashtag, it is temporary file called temp. The fields ID and diagnosis are selected and put into temporary file called temp. The where command filters the data. Here we see a statement that the data where the age at death is greater than the diagnosis should be included in the temporary file called GoodData. Presumably, errors data entry has led to some cases showing that they have died, but the patient continues to visit later. These cases are deleted, and only the cases where death occurs after all diagnoses are kept where command filters data. You may think that a visit from a dead patient is not possible in rare situations. Some visits occur after death, for instance. The transport of a dead patient from home to hospital may lead to recording of an encounter. Other scenarios can also exist where the patient has an encounter after death. These are rare and specific to post-mortality services. The most common reason for encounters with healthcare system after death is due to the date of death being entered wrong by a clinician or clerk in the healthcare system. Check the date entered against the date of the computer recorded for the entry. We may be left with an error date of death. One of the first steps in cleaning the data is to identify patients whose data of death occurs before the date of various outpatient and inpatient encounters. The group by command is one of the most important commands in SQL and allows reporting of field values for a specific subgroup of data. Here the group by command forces us to keep only one ID per person whose data are good to go. Note that we no longer can include the diagnosis field. Any field that is included must be aggregated so that it shows how the field is calculated by subgroups. Here we have included the count of the field diagnoses for each subgroup, defined by the group by statement. The function count is an aggregation function. It will report the number of diagnoses that each unique person has. Note that these are not necessarily distinct diagnoses, just distinct individuals. If we want to know the number of distinct diagnoses, we would need to use the qualifier distinct in the count function. To summarize, in this code, the select ID command tells the system that we are not interested in finding the ID of the patients. Note that we do not need to identify the source of the ID field as this query only has one table, so there is no confusion where the variable comes from. It is always best to specify so there is no room for confusion. Thus, we should use select dbo.data.id. The INTO file command says that we should include these IDs into a file called GoodData. The from dbo.data command says that we should want to get this information from a permanent table called data, which incidentally includes both age of death and age of diagnosis. The where age of death is greater than the age of diagnosis command says that the age of death must be greater than the age of diagnosis. The group by ID says that we would only want to see one value for each ID, no matter how many times a person's diagnosis occurs before death. Also note that the where command must be executed before the group by command. The select command is executed after the group by command. The command having is the same as where, but executed after grouping is done. In this code, we have dropped the where filter and added a having command. The having command is executed after the group by statement. In group by, we are saying that the data should not be grouped by a unique person, unique IDs. Note that now we are examining the data by different persons. We no longer can use the fields age of death or age of diagnosis without aggregation. A person has many diagnoses, and we need to clarify for the code how we want the information to be summarized per person. We had previously used the count function. Here we are using the minimum and the maximum aggregation functions. In particular, we are taking the maximum value of age of death for each patient and then comparing it to a maximum report age at various diagnoses. Now is a good time to try the code on your data and see how far you get. Remember, in the case of error, you need to check the website to figure out the exact format of commands and the data. Also note that the name of the fields in your file may be different. A lot may go wrong, but you never know until you try. Repeated trial and errors can get your SQL code to work. Also, repeat the code using having to see what you will get different. See how where and having lead to different selections.